Hey, ladies and gentlemen, we have our Math 8 lesson 10.1 exponents. I can write and evaluate expressions involving exponents. Now, one key thing here that we're going to learn today is obviously being careful with our negative signs, as we've been trying to explain to you throughout the year. Tiny mistakes occur with the negative signs, so please be very careful with them. As we notice the parentheses, you got to be aware of, do we have parentheses or are the parentheses missing? All right, so let's give it a try. All right, so what we have here is just your general concept. You've already practiced this before. You did this in chapter 8 with our volume. We've got 5 to the third power. So we have our base here, which is our 5, and then we have our exponent here, which is obviously our 3. Now, as we have learned before, on your calculator, you just type it in, or we've even asked you to memorize it. But using the general concept of exponents, we're going to say that it is really equivalent to 5 multiplied by 5 multiplied by 1 more 5. But again, you already knew that, but we're just going over our general information before we get into more specifics. Again, especially involving negative signs, but even fractions. So again, third power means write it 3 times, essentially. 3 factors of 5. 5 times 5 times 5. All right, so on these beginning examples, you really just simply have it written out for you, and you're going to go ahead and change it back to like what we saw here. So for example, 5 times 5 times 5, that's really 5 to the third power. So if you notice, you see it, let's count, 1, 2, 3, 4, 5 times. So obviously we're going to have a power or exponent of 5. Now if you notice, we have our parentheses. That is key. We have our negative sign inside parentheses. That is key. So really, everything is just duplicating 5 times. So we're going to write it with the parentheses, with the negative sign inside the parentheses, with our exponent of 5, because they are all the same. Looking at these two examples, if you notice on example B, we have only sum in parentheses, with the negative sign inside. And then on example C, there are no parentheses at all. So again, it means a little bit different. So if we were to look at example B and identify kind of like our like terms, if you will, or just that common base, we have a negative 9 in parentheses, and we have a total of 3 times. So the exponent would be 3. Our other base is a 4. We have it twice, no parentheses at all, exponent of 2. Now obviously we could multiply this all out together later on, but right now we are just getting in the habit of writing it using exponents, because remember, you could also do the exact same thing with your variables right there. All right, so as we already discussed, again, no parentheses on example C. So it means that negative sign is really just kind of thought of really as a negative 1. Then using alphabetical order, we're going to go to our A first. So we have 1, 2, so obviously it's going to be a squared. And then our B letter, 1, 2, 3, the variable B is going to be a exponent of 3. So again, it's really just being able to write them differently. Now later on, when we teach you some different skills, we're going to go ahead and learn how to unwrite them, if you want to think about it, kind of expand them out, just like you saw at the beginning of example A, B, and C. All right, one of our key things here is obviously knowing the difference between when we have the parentheses, not parentheses. But if you notice on this case, we have parentheses for both of them. So my question to you, as it says up there in that corner, what is the difference? So I'm going to give you a moment to think about that and go ahead and... Oh man, I was going to say talk to your partner. Maybe you can talk to your partner. Maybe your partner is your sibling. Maybe your partner is your parent. Or maybe you could even do some digital learning with doing FaceTime or doing the Google Meet and so on. All right, so what's the difference? If you notice, the difference is clearly where the negative is placed. So on our first one, that negative 4 inside the parentheses, that means my base is negative 4, my exponent is 2, so really I would write it twice. Negative multiplied by negative, as we know, is a positive. And then on the other one, the negative sign is outside, so that means my base is really just a 4. So it's really kind of thought of as the opposite of 4 squared. So the opposite of 4 times 4, if you want to think about it that way, which would be a negative 16. So the key difference is in the base. Where is the negative sign located? All right, so we got just a few sample problems to go ahead and practice what we just briefly talked about, and then you have your assignment to complete. All right, so if you notice, identifying our question kind of back here, what's the difference? So the negative sign is outside the parentheses. So that means we're going to have a single negative sign. Our base is 1 over 6, and my exponent is 3, so that means I'm going to write my parentheses with my fraction inside a total of 3 times. But remember that negative sign in the front only once. It's kind of like a negative 1. So we've got fraction, repeat, repeat. So we've got 3 fractions there, all identical. Now, we should be able to assume or just know that our answer is definitely going to be a negative. And then we're going to go ahead and practice our basic multiplication. 1 times 1, well, it's just 1. And then 6 multiplied by 6 multiplied by 6. Now, if you have it memorized still from when we talked about that way back when, remember those quick little 3 to 5 minute assessments for memorizing your squares and your cubes. So we really have 6 times 6 is 36. But if you knew it, again, it's negative 1 over 216. So again, the key was the negative sign was outside. All right, moving on. This one, though, if you notice, the negative sign is inside. So that means when I expand it, I'm going to go ahead and write my parentheses with my negative 2/3 inside a total of 4 times. Because again, the negative sign is inside. The base was different than our previous one. Now, if you want to think about it in multiple thoughts or multiple steps, I personally like doing the signs first, then I'll do the actual numerators, then I'll do the denominators. So negative multiplied by negative, positive. Negative multiplied by negative, positive. So positive multiplied by positive. Hey, they're all positive then. So that means I really just need to multiply my numerators. 2 times 2 times 2 times 2. Then do the same thing with my denominators. 3 times 3 times 3 times 3. There will be some shortcuts that we will teach you later, but right now we are just going ahead and expanding it and then multiplying it. So we really have a 4 multiplied by 9, because remember, a negative multiplied by negative is positive. 2 times 2 is 4, 3 times 3 is 9, and then I have another 4 over 9. So instead of just going across with the numerators and across with the denominators, I went ahead and broke it up into like 2 mini problems. And then obviously we multiply it and we have 16 over 81. But again, the key was, where was the negative sign located? All right, our last few problems is practicing our order of operations, including our exponents. Now, again, you may have that whole, please excuse my dear Aunt Sally. And again, that is valid here. So let's go ahead and look at our evaluating problem. Now, if you remember from those basic steps, you cannot do 3 plus 2 first. Please make sure you do not do that. Let's see. Please, parentheses, excuse, exponents. There we go. Let's do our 3 to the 4th power. Now, 3 to the 4th power, the base is just a 3. Really thinking about it as 3 times 3 times 3 times 3. So a total of 4 times, because the exponent of 4. Which gives us an 81, because it's really 9 times 9, 81. Now, to continue on, I'm still not going to do my 3 plus 2, because again, my after exponents, please excuse my multiplication. 2 times 81, 162. And then finally, you will add at the end, 165. Very nice, very nice. All right, let's try this one right here. Ooh, interesting. So this is where some students have difficulty. Your parents and myself were on Facebook, because again, that's for old people. Sometimes there are math challenge problems on there, and some students, or some parents, some adults, unfortunately get it incorrect, but you will get it correct. All right, exponents first, because we don't have any parentheses. So 3 cubed, you should already have that memorized. 8 squared, you should already have that memorized. But if you didn't, remember, it's 3 times 3 times 3, and then 8 times 8. So we have 27 subtract 64 divided by 2. Now, most people would just go left to right, but remember, it is order of operations, left to right. So we're not going to subtract before we divide. So I'm going to go ahead and do my 64 divided by 2 first to give me my 32. Then I will finally subtract. 27 subtract 32, practicing our skills from the beginning of the year. Remember, they are different, so you can change it to adding the opposite if you'd like to, or you can just remember taking the difference means subtracting, and taking the sign from the greatest absolute value, which would be the 32 with the negative sign, so it would be -5. You being awesome digital learners? I sure hope so. All right. What we have here is a combination of multiple items, but again, we're not going to worry about it. We're just going to go in order. And then, of course, we also have those wonderful absolute value bars that we will address again. So let's see here. Our base, notice how the negative sign is not inside the parentheses. So it does not mean -3 multiplied by -3 multiplied by -3. Don't think that way. It's one negative sign only because there are no parentheses. So we know that 3 times 3 times 3, or 3 cubed, we've had that memorized, is 27. So I really have it as -27 divided by 27 absolute value bars. Still working inside the absolute value bars. I'm going to go ahead and do -27 divided by 27, which would be giving me a -1. And then finally, the absolute value of -1 is +1. Again, we're doing our order of operations, also being careful of our exponents and our bases in particular. Ooh, a fraction problem. Very nice, very nice. Remember, the great thing about digital learning with my awesome videos is you can pause it anytime you need to, back it up, look at it, view it with your parents even. Maybe they want to learn some 8th grade math as well. So let's go ahead and work on this problem. So we're going to go ahead and pause with a fraction, work inside our absolute value bars. We're going to do our order of operations correctly. So we've got 5 squared. We already know that. And the question is, what am I going to do next? Am I going to do 25 subtract 2? Or inside the absolute value bars, am I going to do 2 times 15? Give you a moment to think about that. Which one should I do next? Yes, that's correct. We're going to go ahead and multiply. So I really have 25 subtract 30 with the absolute value bars. We know that 25 subtract 30 inside the absolute value bars would give me a -5. We know the absolute value of -5 is +5. All right, now we have a problem very similar to what we had at the beginning of the year when we were trying to work with your fraction skills to help you, again, be awesome in preparation for high school. Got to have those basic skills ready to go. So remember, 5 is really 5 over 1, and then you can go ahead and convert that into a common denominator, multiplying the denominator by 3 and the numerator by 3. So going back a step again, you would have a 1 underneath the 5, multiplied by 3 for the numerator and denominator, and that's how you get your 15 over 3. Now that I have it at this point, I can go ahead and combine essentially like my like terms. My denominator will stay a 3, and then I've got a -2 plus 15, which is going to give me a 13 over 3. Now, from that point, I cannot reduce my fraction, but if you want to practice your skill from 7th grade or earlier, you can convert it into a mixed number. 3 goes into 13 so that you have 4 whole pies. Ooh, I love pies. So that would be 4 and 1/3, because 4 times 3 is 12. 1 piece left over for your additional pie. That's really big pie slices. Only 3 slices per pie. Yummy. But in 8th grade, we primarily like to keep it as an improper fraction. All right, unfortunately, that is our end of our time. So you're going to go ahead and be awesome and do the best that you can, please. Be awesome math learners.